All right, so you have a paper that looks like this. You've got a bunch of lines on your paper. Now, these are actually what we call line segments, okay? So whenever we have a segment, that basically means that we are looking at a portion of a line. This is a little part. So everybody, you have a ruler. One side of your ruler, you're going to see inches. When you flip it around, the other side, you're going to see centimeters. Now, we do not, I think we use the, what is it called? The imperial measurement system rather than the metric. So in the imperial system, we like to do things that don't make a lot of sense, and we'll talk about that later. But we use inches for measurement, inches and feet. So whenever you are measuring something, I'm going to ask you guys this. Would the correct way to measure be lining up the, oh man, that glare is going to kill me. Let's do this. To line up the end of the ruler to my first point, or to line that first line on the point? Which one you guys think? The first line, good. So rulers, this is the biggest mistake that some people will make, is you think, okay, I'm just gonna line up the edge of the ruler here. You actually want that first line. That is your starting point. And you're gonna see that there's a whole bunch of teeny tiny little dashes in between 0 inches to 1 inch. So in between those lines, here's what those dashes mean. I made this last night. Spent like way too long on it. It was bad. This is called the giant inch. And basically what this paper is going to show you is what all the little miniature things, the little lines or little tick marks in your ruler are. So what I did here is I took this inch and I blew it up real big. So this paper, gosh, if I could make this higher. Let's see. There we go. Now we can see the whole thing. So this is just kind of a blown up 1 inch. This is 0. This is 1. At the halfway point of your inch, we have 1/2 inch, half of an inch. Whenever we go to each section, it's going to be counting all these different fractions. So we start over at 1/16. Then 2/16 or 1/8. Then we've got 3/16, 4/16 or 1/4. Okay, and we go on and on and on. So whenever we are measuring a line, for example, let's have our paper flipped to where the 2 lines are on top. I probably should have made the paper more clear, which is up and which is down. I would like for you guys to measure this line right here by putting the starting line right on the edge of the point, and I want you to see where that end line falls. And we can use this little chart to decide what fraction we land on there. So once you think that you have got the correct measurement, go ahead and use a pencil in case you write the slightly wrong answer so you can erase it. Go ahead and label this line here. So I can already tell it's at least 2 inches. Is it 3 inches? No, it's not quite to the 3. So we know it's going to be 2 and something inches, right? So I'm going to write a 2. And let's figure out the fraction now. So let me get this real tiny. Make it a little closer. Y'all, we're struggling. Okay. Come on. Okay, so I've got my line right there. And it looks like this line right here is my stopping point. Does everybody see that? So if we start at 2, in between 2 and 3, this is my halfway point. Let's look at our giant inch. There's the halfway point. And then we are going, how many past the halfway? Let's see. 1, 2, 3, 4, 5. So let's count on here. There's the halfway. There is 1, 2, 3, 4, 5. So the measurement for this line should be approximately 2 13/16 inches. Did you guys get that? You guys get at least close to that? Yeah. Good. What answers did you get that weren't 13/16, or did you guys all get that? What did you get?
I got 3/4
3/4 at first? What else? Did everybody either get 13/16 or 3/4? Which?
13/16 for the second guess.
Ah, second guessing. That is common. That's okay. So let me see. Ooh, yeah, it's super close to the 3/4. This would be the 3/4 right here. But remember, we were going to measure all the way to the end of that dot there. The dots make it a little confusing, I think. We're going to use this for something else as well. But whenever we're measuring, we're going to be looking at all these little tick marks, and we want to take it all the way to the outside of the very end point there. Okay. Anybody have any questions about that? Any at all? Okay. I would like you to measure the second line, this tilted one. And let's see what we can get for that. And I'm going to actually take this inch thing, and where I can put this so everybody can see it. I'm going to put it right here. I should probably print out a bunch of little ones of these for you guys to have. Okay. Yeah, that's pretty tough to see, isn't it? Oh man. Okay. How about this? Let's first, in your notes, I'm going to make this big. I'm going to give you guys a moment to copy this down so that you can have your own little reference for it. So, on your paper, if you would like to make yourself a little guide of all the different fractions within the inch, I'm going to keep it up here for a second and let you guys do that. And I'll pause this recording so that it's not just us sitting here silently. Okay. What measurements are we getting, guys? Same one. Oh my Lord. That's probably my fault. Let's see. Okay. 1 right there, and wow, yeah, that's pretty close. I think that is exactly the same line. Okay, I picked the bad one for you to measure in again. Did everybody get the same answer? Okay, well, then good. Y'all did it right. Okay, so using a ruler is not too tough. Typically, in real life, whenever we're measuring, I don't know, like a window or, you know, a distance from something, unless you're in construction or some sort of profession where you need to be extremely exact, a lot of times we'll round to that nearest half inch or 1/4 inch, or I'll say like, okay, 3 inches and then 5 tick marks. So just as long as you guys know to line it up on that first little line and take it all the way to wherever the end is touching on the next line, that is how you're going to measure with a ruler. Okay. How we feel about rulers? Not too bad. All right. So whenever we do eventually take a quiz, basically there's going to be one question at the beginning of your quiz, and there'll be a line. I'll have you measure it. That's going to be the only time I'm going to want you to be accurate with the fractions. Okay. So that's really all there is to the rulers. let's introduce one more tool that we use in geometry. We're going to come back to the lines, but first let's flip our page over. And you're going to see we have some angles. So what I'm going to have y'all do, I'm going to put this ruler bin up here. I would like you, actually keep your ruler. I'm going to have each of you take one of these out of this bin and pass it around. We are going to use a protractor today. Is anybody in this room, has anyone never heard that word before, protractor? You've used one? Well, good deal. Heard of it, never used it? Okay. Well, you're going to use one today. You're going to use one today. So this is a protractor. I'm going to wait till everybody has one. Thank you. All right, everybody got your protractor? So a protractor in geometry, this is what we use to measure and draw angles. Now I'm actually going to grab one that is identical to yours so that we can be pretty exact. So let's start by looking at this first angle here. When we measure an angle, we are trying to see at what direction are these two lines pointing. So we need to make sure that we are lining up the correct starting point, just like we would line up on a ruler. So your starting point on a protractor is actually going to be this little dot, this little intersection at the bottom middle. So what you're going to want to do is take that dot and line it up with where the two lines are meeting on your angle, just like this. Does anybody know what this little intersection is called on an angle? Starts with a V. It's called a vertex. Everybody say vertex. Vertex. So a vertex, this is one of your first kind of vocabulary words. A vertex, here I'll label it. A vertex is just a point where two lines are meeting. It's going to be this little point where an angle is made. There's always going to be a vertex as your starting point to measure. So we're going to line that protractor up with our vertex. We're going to make sure that the bottom line, you see that there's a line beside the hole. You want that to be lined up perfectly with the bottom line of the angle. Okay, now if I were to do it like this, see how my line is slightly below? I'm going to get an inaccurate measurement. It's not going to be correct. I want it to be very precise. We always want to be precise in math. Now, once you've got your vertex lined up in that little circle, you've got your bottom line of the angle lined up with this bottom line on your protractor, we are going to follow the top line all the way up, and we want to see where it lands. These numbers at the top are going to tell us our angle. So as you see, we've got two sets of numbers. All right, we have 10, 20, 30, 40, 50, keep on going, starting from the right, going left. And then we've got another set of numbers on top, 10, 20, 30, 40, 50, all the way up to 180, starting from the other side. Which set of numbers, the numbers on the outside or the numbers on the inside, which set of numbers do you think that we're going to use to measure this angle in particular? Say that again? On the inside. So what made you think that the inside would be correct? Yeah. So basically, what these numbers are telling you is kind of the direction at which that angle is opening. So you can think of an angle almost like a book or a folder. I'll show you on here. So whenever we have an angle, our vertex is like the spine of the book, and it opens up this way. As it opens up more and more, the angle gets bigger and bigger and bigger. So with this angle, it looks like we are starting here and it's opening up this way. So the inner numbers, we see that starts smaller, getting bigger. It wouldn't make sense to measure this angle with the outside numbers because this is starting with 180 degrees, and that is not the correct number here. Okay, does anybody have questions about why we're using the inside numbers rather than the outside? Does that make sense to everybody? Okay, so about where is this angle falling? About 45 degrees. It looks like it's right on the dot there. So we are going to label this angle, and I'm going to put 45. You guys know how to write degrees? You know that symbol? Yep, just a little circle in the top right hand corner. So this angle is 45 degrees. Very good. Okay, now just in case this one is similar, let's do the one below it. I would like you guys to try to measure this angle. Now this one's a little different because it's not sitting where the flat end is sitting kind of flat like this one is. It looks like this angle is tilted, so you're going to need to hold your protractor in a different way. And tell me when you think you know what this angle might be. I'm going to measure it myself too. Okay, let's see. Okay, and I've noticed an issue that we might run into with this angle. If you start with your protractor here, you notice that this line does not extend all the way to where the angle measurements are. So you might be tempted to just draw a line outside of it. If you do need to extend one of the edges of an angle, always use a straight edge surface. So you can either take your protractor and line it up and trace the line to make it longer, or you could use a ruler for that. But in geometry, we got to be very exact, because if you try to do it freehand, as accurate as you might be, one little tiny wiggle could make it wrong by 1 degree or so. So you want to be as exact and precise as you can be. What are you guys getting as the measure for this angle? 70. About 70? Anybody get something different?
I used the wrong number, but yeah, 70. I put out 110.
Ooh, 110, 70. Okay, I'm hearing a couple different answers.
Well, yeah, I used the wrong number, but like I used the ones we weren't supposed to. So I'm not 110, but it's supposed to be 70.
So let's talk about it. Is this 110 or is it 70?
It's 110. Because don't we use the bottom numbers?
It's 110. So you did it right. So we want to think about what direction this is opening from. If this were a book and it was closed, when we open it up and the angle changes, you're going to start from 0, and then it goes up to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So did you do it this way?
Yes.
Okay, so if you decided to measure it from here,
It still gets on, and you just gotta look.
yes. So you might think, oh, well, if I measure it here, is it going to be 70? Well, did the angle change? Did it get smaller? No.
Just let it flip the other side.
Yes. So this time, like if we were going to do it this way, where this is the bottom of my book, and here is where the flap is closing. That would mean that the angle gets bigger from here, and the numbers on the outside would represent the angle. So we start at 0, then 10, 20, 30, 40, up to 110. So we'll get the same measurement no matter which way you do it. Just make sure that you're thinking about which way would this open if it were a book. And whenever it is opening, where am I starting from 0? When I open this way, 0 is on the outside, starting getting bigger. If I were to do it this way, 0 is on the inside, starting and getting bigger. All right, so this angle, we can label it. I'm going to put a little arc inside, and we're going to say it's 110 degrees. Oh, someone's at the door. Hello, how are you doing?
I don't know, I'm supposed to be right now.
That's okay. Are you geometry or are you algebra 2?
Algebra 2.
Okay, algebra 2. So you are in the right place. This is where it will be, but it will be starting at 10:30.
Okay.
So just about 15 more minutes. All right, I will see you in a little bit. Okay, so we've got our angle measurements. Now I would like for you guys to measure the angle next to it right here. And tell me what you get for that. I'll kind of measure quietly up here while you guys do that. Let's see. Okay, once you think you've got the measurement, go ahead and shout it out at me.
97 degrees.
Okay, 97. Anybody get something different? 95. Anything different? Okay, so what 80s are you guys getting? 84?
About 82, 84.
Okay. So we're getting two different answers. Let's talk about which one's correct. Is it in the 80s or is it in the 90s?
I get where the 90 would come from if you're looking at the wrong spot.
Yes.
80 lines up with the hundreds. And 90 lines up with the 90 itself. So
Yeah.
that's a problem.
So here's a little trick to remember. Does anybody know what a right angle is?
Isn't that like 90 degrees?
Yes. So a right angle is an angle that is 90 degrees. That's going to be an angle that goes perfectly up and down. So that's going to be like the edge of a paper. If I were to measure the angle on the edge of a paper, it will always be, as long as it's a normal piece of paper, it's always going to be right at 90 degrees. So anytime you're looking at an angle, if you can tell that it is less open, if it's a little more closed, if it's not perfectly up and down, you know it's always going to be less than 90 degrees. If it is bigger or past that straight up and down point, it's going to be bigger than 90 degrees. So let's just real quickly look at this. Is this bigger than 90 degrees or smaller? It's smaller than 90 degrees. So if you got an answer in the 90s, let's rethink it. Let's look back at your angle and see if you can come up with a different answer. About 83, I heard 84, 85. Okay, so as long as we are within 5 degrees, I will take that. These are a little bit trickier to get super accurate answers, but that is absolutely correct, you guys. We start opening from here, so we're reading the inside numbers. So we go up to 80, not quite to 90, and I'm going here, 81, 82, 83-ish, 84-ish, somewhere in there. It won't be perfect, but you should get around 82 to 84, 85-ish. All right, so let's go ahead and label that. I'm just gonna label this 84 degrees, because that's like a happy medium. All right. How you guys feel about that? Not too bad, not too bad. Takes a little practice, but it's not terrible. Okay, we have about 5 minutes left, so here's what I'm gonna have you do as your first exit ticket, first grade. I would like for you all actually to, on this page, I want you to measure the angle of this angle right here at the bottom left, and then with your ruler on the other side, I want you to measure the smallest line, the shortest line right there. Okay. You measured them? Well, then you are in great shape. So once you have measured the angle and the line, I need you to write your name on the top of your paper, doesn't matter which side, and you will turn it in over here. This is where you turn items in, guys, so if you want to look up real quick, this is our turn-in bin. This is where you'll turn in any exit ticket, any assignment, and it will always be right up here. Once you have finished that, you are free to go. That is your first day of geometry. I'm going to end that recording.